covalent bonds. By covalent bonds, there are, for example, two atoms coming together, but they are not losing or gaining an electron during that process. There can be single, double, or triple covalent bonds, but there can be multiple single bonds, for example. So there's, for example, hydrogen. Hydrogen can make together with another hydrogen atom a singular covalent bond. Now, both hydrogens have one electron on the valence shell, and there fits a second electron on the valence shell. So there's a hydrogen with one electron on the valence shell. But on the first valence shell, there can be two. So it can come together with another hydrogen with one electron on the valence shell. Now they come together and both have now two. They are sharing now one. But it's a singular covalent bond. Singular covalent bond. The more a double or triple one holds stronger. Now a double covalent bond would, for example, work with oxygen. Oxygen has 8 electrons. 2 on the first shell is full, but the second shell can hold 8. Oxygen has just 8, but the first 2 electrons are already on the first shell. So it has just 6 electrons on the second shell, which can hold 8. 2 more. So it can team up with another oxygen. They can come together and they're having now shared 2. So 2 electrons from the other electron came over and 2 from that one over to that one. They are sharing 2. And that is now a double covalent bond. And it can be seen that the electrons are actually shared most of the time in the middle between these two. Now a triple covalent bond, that would be, for example, nitrogen. Nitrogen has 7 electrons. 2 on the first shell and then 5 on the second shell, which can hold 8, so 3, and 3 going over, 3 coming, 3 have been shared basically, so they're not going over. They're not gaining or losing electrons, they are just in the middle, and they are shared by both. That is a triple covalent bond. Now, there can be also a bond, for example, with CH4, methane. So carbon, and then carbon has 6 electrons, and H4, so 4 hydrogen. Hydrogen has 1 electron, carbon has 6. Carbon has 2 electrons on the first shell and then 4 on the second shell. The second shell can hold 8, so 4 can fit there. And hydrogen has 1 electron, so 4 hydrogen can bond together with that 1 carbon. And then we're having CH4, carbon 1 time and hydrogen 4 times, CH4 methane. Now there can be also, for example, water, that is H2O. So we're having 1 hydrogen, 2 hydrogen and 1 oxygen. So the oxygen, it has 8 electrons. It must be 10. 10 electrons, 2 on the first shell, and then 6 on the second shell. So 2 can come there more with 2 hydrogen things. 2 hydrogen can now come to, and then we're having H2O. So 2 times H, 2 hydrogen, and 1 over this oxygen, which is H2O, water. And now by that thing, that would be a polar bond, because now the oxygen is pulling stronger at the electrons which is shared from the hydrogen, as the hydrogen is pulling at the shared electrons. So a polar bond. That is now signified through the Greek delta plus or minus, the electronegativity. So there's basically said the hydrogen has a little plus electronegativity because the electron is a bit further pulled to the stronger oxygen away from it, and so the hydrogen is a bit more positive because the negative electron is pulled away from it. The oxygen is then more negative. It has the delta sign almost looking like a swan song, with something on top. It is pulling stronger at the electron, and therefore that has an electronegativity with a delta minus, because it's pulling stronger the shared electron of 2 hydrogens to it. The opposite is a non-polar bond, that both are pulling with the same force. And these polar bonds work, these covalent bonds work not just with the same element, like hydrogen, but also with water, oxygen and hydrogen. Ionic bonds do it only with the same, if it's right understood here. That is according to ZREJDVDC and Sarah Grabowski's Physicals of Anatomy and Physiology book on the pages 31, 32 and 30, but this is no medical advice.